Hey, how's it going, guys? Happy Thursday. First things first, I need you to go ahead and open up your math notebooks, find a clean page, and title it Slope-Intercept Form. Now, if we remember, on Tuesday, we took a look at slope, or rates of change, or specifically how the number of tiles increased as our figure number increased for a particular pattern. And then we also took a look at starting value. So for figure 0, how many tiles did I have? What was the constant amount of tiles that I had all the time? And like where was I adding my tiles for that particular pattern? So for slope-intercept form, what slope-intercept form is it is like a standard equation for a line where you've got 4 things. You have y, which is your output. So in the context of the problem that we dealt with on Tuesday, that was our number of tiles. You have m, which is your slope, so y equals m. So our slope, remember that's our rate of change. So again, if we call back to Tuesday for the pattern that I did in the video that was posted for that assignment, we were increasing our number of tiles by 3 every time our figure number increased. We have x, which is our input. And then we had b, which is our starting value. It's the y component of the xy ordered pair of our y-intercept. So just think, if I set x equal to 0, what's y going to be? So you have b, which is your starting value which you get from your y-intercept. So, slope-intercept form, the equation, here's the big thing to write down. It's y equals m times x plus b. And again, y is your output, m is your slope, x is your input, and b is your starting value. So let me give you an equation in slope-intercept form, and we'll talk about it. Y equals 2x plus 1. So if we were to graph that equation, our starting value would be 1. So if I plug 0 in for x, I'd get y equals 2 times 0 plus 1. And the y value, when x is 0, is 2 times 0 gives me 0. It's 1. So my y-intercept is 0, 1. That'd be the ordered pair. So if I were to graph that on a coordinate plane, you've got your x-axis, and you've got your y-axis. From left to right, it's nowhere. I'm not going left, I'm not going right, it's because it's at where x equals 0. But on the y-axis, I'm going to climb up to 1. And that would be my y-intercept. But then what if I wanted to graph some other points? What if I wanted to plot some more points on there? Well, let's plug in 1. Y equals 2 times 1 plus 1. And I get what? Well, 2 times 1 is 2. 2 plus 1 gives me 3. So now I have the ordered pair 1, 3. So when x is 1, y is 3. Let's plug in another value. When x is 2, what's my y value going to be? It's going to be 4 plus 1, which gives me 5. So I have another ordered pair. When x is 2, y is 5. And when I plot that point, you can see the pattern. I'm going to get a line. And you'll see it a little more evidently when you plot things on Desmos rather than me freehanding it right here on the board. But your equation, y equals m times x plus b. You will always have y and x, because I'll ask you to plug in values for x, much like I did when we dealt with functions a couple of weeks ago, and then you're going to get an output, which would be your y value. So every single time you write an equation in slope-intercept form, you should have y equals something times x plus b. The m and the b are what's going to change based off of your y-intercept and your slope. Now, let's go ahead and take a look in Desmos at screens 2 and 3 for our activity and see exactly how I can graph a line in slope-intercept form that meets a certain set of requirements. Hey, how's it going, guys? So what we're going to do right now is we're going to take a look at Screen 2 in Desmos. So you guys are going to answer this question in the next activity, and feel free to use the exact equation that I give you guys because I'm more worried about you doing the work in the next few slides. But we're going to graph a line that goes through the point 2,5. So we can already see right here that we have a point plotted that's just staying there on the graph. And if I go over here, it's where I can start entering things in the graphing calculator for Desmos to graph. So I want to plot a line, and I need it to go through that point. But first, I need a line. I'm not given a y-intercept, nor am I given the slope. So that means I get to do whatever I want to make a line that goes through that point. So let's take a look. I'm just going to type in y equals 3x. That's pretty similar to the line that we were dealing with in the lesson on Tuesday, right? Our tile pattern, it increased by 3 tiles every single time we change figure numbers. But it looks like the line actually goes above the point that we need it to go through. It's not going through 2,5, it's going above it. So I zoom out real quick, and it looks like I need to make it lower. Looks like I need to bring the line a bit lower. So what if I make the y-intercept, instead of it being 0, 0, what if I made it -1, 0? So I make it 3x minus 1. And if you see, you have the y-intercept of 0, -1. It has an x-intercept of 0.3330. But the main thing is it does, in fact, go through the point 2,5. Because if we go up from -1, we go up 3 over 1. That gives us the point 1, 2. And if I go up 3 over 1 from that, I get the point 2,5. So I would simply leave this equation for a line here on this slide and hit next. So now we're going to take a look at, we want a line that goes through the points -3, -2, and 3, 10. So here is the point -3, -2, and I've got to zoom out a little bit, and you'll see that there's already a point plotted for the point 3, 10. So let's make sure that we have both points in view and that we can see the grids, and let's go ahead and take a look at the lines and see what we can graph. So they seem pretty far apart, right? There's quite a bit of vertical distance, quite a bit of horizontal distance. So what if I found out the change in y and I found out the change in x? So if we start here at -3, -2, our y value here is -2. And so to get up to 10, I need to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's a vertical change of 12. So if I'm going to come up with my slope, I know that I'm going to have 12 over top of something. Now, what's our horizontal distance? Well, I went from -3 to 3, right? So let's count from left to right. I'm starting down here at my farthest point to the left, the first point that I see if I'm reading the graph from left to right. And I have to go 1, 2, 3, 4, 5, 6 values to the right. So my horizontal change is 6, or my change in x, my delta x is 6. So I'm going to type that into the graphing calculator. Now, just putting y equals 12 over 6 gives me a horizontal line, right? What's 12 divided by 6? It's 2. So this is just the vertical line y equals 2. But if I actually want it to be a diagonal line that goes through both points, I should have it be 12 over 6 x, right? My slope is 12 over 6. Now, I know we can simplify that and just make it 2 over 1 because 12 divided by 6 is 2. So it could also be 2x, but it looks like my line is below those 2 points, right? You've got your point 310 right here, and -3, -2 right there, and my y-intercept is the origin, but my line's not touching those points yet, but it might. So let's see if we can shift it up. I added 1 and it didn't work. I added 2, still below. I add 3, and it's still below. But when I add 4, we're good to go. So taking a look, we started with just y equals. We found our delta y and then our delta x. We came up with that ratio. It was 2 to 1, but Desmos is nice and automatically simplifies it. And we graphed a line that was below it. So I have my y equals m times x. I have y equals 12 over 6 times x. But I need my b. I need to know what the y-intercept has to be in order for the graph to actually go through those lines. So I added 1, and it didn't work. I added 2, I tried 3, and when I tried 4, it worked. So my y-intercept now is 0, 4. So the line crosses the y-axis when y is 4 and x is 0. And now my line goes through the 2 points that were described in the graph. So as you guys move on and you take a look at screen 4, you're graphing a line that has a slope of -3 and goes through the origin. So if it goes through the origin, what's your y-intercept? If it's got a slope of -3, what's the equation of your line going to look like? Remember, you need y equals something times x plus or minus something. Looking at screen 5, you need a graph that goes through these 2 points. Click on those 2 points to find out where they are, find the vertical change, find the horizontal change, and you have your slope. Graph y equals m times x, so y equals your slope times x, and find the y-intercept. When it comes to number 6, you need to graph a line that grows by 4. So the pattern that this line represents grows by 4 every single time. So if x is increasing by 1 and y is increasing by 4, what is your slope? Give me any kind of line that fits that requirement. And then the last one, I need a line that goes through the point 8, -1 and has a slope of -3/4. So if you take a look, you've already got that point. It's graphed. But what you should do is you should have y equals -3/4 times x. And now all you're doing is you're messing with that y-intercept and trying to increase it or decrease it to get that line to hit that point. If you guys happen to have any other questions about what to do for this activity, I'll see you in my office hours. But best of luck.